Is supplemental instruction really making a difference? Or are stronger students just more likely to seek help? Let's say students who attend supplemental instruction also tend to have higher GPAs. At first glance, that looks like supplemental instruction is working. But hold on. What if those students were already stronger to begin with? To figure that out, we need a way to control for academic preparedness while evaluating the effect of supplemental instruction. That's where analysis of covariance comes in. Our question is, does supplemental instruction actually improve GPA outcomes when we adjust for how prepared students were academically, using ACT math score as a baseline? We're asking whether supplemental instruction still matters after we've statistically leveled the playing field. This is a case for analysis of covariance. Here's why. Our dependent variable is GPA, a continuous outcome. Our independent variable is whether or not a student used supplemental instruction, a categorical group. And we're introducing a covariate, ACT math score, to control for students' incoming academic ability. ANCOVA lets us test whether supplemental instruction has a unique effect on GPA, beyond what we'd expect based on ACT scores alone. And if you're thinking about using this test in a formal research project, here's a full walkthrough of the study design you'd want to document. Start with your research question and hypotheses. Then we want to define your variables clearly. What's the outcome? What's the grouping variable? And how are they coded? From here, describe your data preparation steps, including how you filtered, recoded, and structured the data. Next, want to explain the method you're using. We should also mention any assumptions you checked. And finally, report and interpret your test results, ideally with the comparison, test statistic, p-value, and what it means in context. This structure turns a simple test into a publishable mini-study. ANCOVA gives us a clearer picture of the true effect of supplemental instruction by removing the statistical noise from ACT scores. It gives us adjusted group means for GPA, as if all students had the same ACT math score, an F-statistic for supplemental instruction's effect, a p-value to tell us whether that adjusted difference is statistically significant. If the p-value for supplemental instruction is below 0.05, we can say, supplemental instruction has a statistically significant impact on GPA, even after controlling for prior academic ability. To run the ANCOVA and SPSS, go to Analyze, then General Linear Model, and click Univariate. Set GPA as the dependent variable. Move supplemental instruction to fixed factors. Move ACT Math to covariate. Then click Options. From here, click Estimates of Effect Size, as well as Homogeneity of Variances. Click through OK. The output will show an F-statistic and p-value for supplemental instruction's effect, adjusted for ACT math score, ultimately suggesting whether supplemental instruction still matters after controlling for academic preparation. The results are powerful. A CT math score is a strong predictor of GPA, no surprise there. But even after adjusting for ACT, SI attendance still makes a statistically significant and substantial difference. As a means to test assumptions, we ran Levene's test, and the results are clear. The p-value is well below 0.05, and this is a test that, should we have a good model, we want to fail to reject this test. Since we can reject the null hypothesis, this means the variances are not equal. That's a technical violation of one of ANCOVA's assumptions. The good news? Tukey's HSD test is considered pretty robust even when variances aren't perfectly equal, especially with a large balanced sample like ours. Also, we see in the effect size scores that each effect sizes are moderate to large, with supplemental instruction at about 0.6 and ACT math about 0.1. The general rule of thumb is as follows. A small effect is 1 below 0.01, a medium effect is around 0.06, which we saw supplemental instruction to be, and large is greater than 0.14, which ACT math is approaching. In short, SI works, not just for strong students, but for anyone who shows up. That's ANCOVA, a powerful tool when you want to know if an effect still holds after controlling for another variable. In this case, we saw whether supplemental instruction improves GPA beyond what ACT scores already predict. Next up, we'll move from group comparisons to relationships between continuous variables as we dive into correlation analysis. Subscribe and stay curious.